Yeah, yeah. Good evening, all. So myself, I'm Vijay. Like I hold 20 plus years of experience in different technologies. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah.
Yes, sir. Your screen is visible and voice is clear.
Okay, fine. So as part of today's demo, I'll be covering the following things. What is a Google Cloud Platform, data engineer and a ETL developer, traditional ETL developer and data engineer, the differences, who is a GCP data engineer and what he does, and what are the roles and responsibilities of GCP data engineer, various GCP data engineer products and services, and job market of GCP. So starting with this, so everything we are going to discuss in cloud that is Google Cloud. So before that, let me give like overview about the various cloud service providers. Yes, various cloud service providers. So we have got AWS, we have got Azure, GCP, Google Cloud Platform. We have got Oracle Cloud, and we have got Salesforce. We have got Salesforce, VMware. We have got Liquid Web, Alibaba Cloud. So in this way, we've got this, but yes, most companies, uh, most companies are preferring GCP, secondly like Azure, AWS. So they're preferring, most companies preferring as GCP, Azure, and AWS. So I can say today like GCP growth is increasing rapidly. Companies are migrating towards GCP. Google uses some infrastructure for the users. See, generally, Google uses some infrastructure for the users for storing some kind of YouTube videos, Gmail messages, Google search engines data, right? In the same way, GCP uses the same kind of infrastructure for storing and for computation. Yes, here we store data. Generally, in here we store data, we retrieve or read data, we perform like kind of data analytics. Here we see high availability of data. So what we do here, generally, we store data, read or retrieve data, perform data analytics. High availability of data. We see high availability of data. High availability of data means if one server is down, we get the data from various other servers. Here, data is safe. Data is safe and secure, just like Gmail. So here, easy to scale, easy to scale means we can increase or decrease as per our requirement. So GCP offers, so it's a wide scope of applications to run like web applications, data analytics, machine learning. GCP is flexible. It can fit in any level of organization. GCP can fit it any level of organization like big or small or large data or small data. Generally, you may ask why to go for GCP. We got like AWS, Azure and GCP. Why we need to go for GCP? AWS, Azure, GCP. So why to choose? Why to choose GCP? So I can say many reasons to choose for GCP. Fast, biggest network in the world. So I can say it is the fast and biggest network in the world. Google has got data center. Google has got data centers throughout the world. It has got they use high-end virtual machines. They use high-end virtual machines, right? So here, secondly, petabyte. We say petabyte bandwidth, high performance because of it, like high performance. Hmm. And also you can see like the storage and the computing, right? Yes, separation of compute and storage, separation of compute and storage. Each individual virtual machine has its own RAM and data storage. Each cluster will have n number of nodes. Cluster means group of nodes, group of systems. N number of nodes we can store. If data stored in single node, if it get crashed, then the data is lost. So in GCP, if one copy is stored in one machine, the other copies are stored across multiple machines. Here from different data centers, we can retrieve data. And also the other reasons for this pricing, even also pricing, right? Yes. Pricing. GCP has got a flexible pricing, right? It has got a flexible pricing as compared with AWS and Azure. Even discounted price, even discounted price of applied for long runs workloads, long running workloads. That is for 10 years, 15 years, right? For those things, many discounts also applied. And even like customization, right? Yes, wide range of customizations for any instance. In cloud we create many instances. For a particular instance we can customize depending upon the requirement. For instance, if you are having 1 petabyte of storage, for example, for if you're having 1 petabyte of storage, right? And even can say like a scalability easy to scale. I said even capacity, if you want to increase or if you want to decrease, it is very easy to scale. And also like live migration, which you cannot see in Azure or AWS. Here we can see live migration is possible, right? Supporting live migration of virtual machines, whatever existing system we have used. For example, you have stored data in Hadoop, you can lively migrate to GCP without impacting the existing data. But Azure and AWS cannot perform this kind of migrations. And also like big data or ML, big data and ML, right? Yes. We get inbuilt and predefined ML. We get inbuilt and predefined ML and AI APIs in GCP. We get inbuilt and predefined machine learning and AI APIs in GCP. And also like free trials, we can see like free trials as compared to that free trials. Some services free for 3 months, some services free for 1 year, some services are free for lifetime here. And also like customers customer systems migration, right? Existing data migration to GCP. Even if we talk about this Twitter, Vodafone, HSBC, like all this, right? Spotify, etc. Existing data migration to GCP. Okay. So if we are coming to this data engineer, right? Data engineer versus a ETL developer, a traditional ETL developer, right? Here also, yes, he has got Data engineer. We talk data engineer, right? Should handle all varieties of data. Should handle all varieties of data. That is should work with structured, that is should work with structured, semi-structured, and unstructured. Should work with streaming data. Should work with streaming data. Should work with the NoSQL data. Should be able to work with should work with NoSQL data, not only SQL, right? It should work with all formats of data. All formats of data, file formats I'm talking. So you should be able to work with all varieties, structured, semi-structured, and structured. Should be able to work with streaming data. Should work with NoSQL data. Should work with all formats of data. All formats of data, right? So here data, here everything deals with the data. Everything deals with the data. Data, today's world flooded with data. Data has experience, data has experience, and data has future reference. Data as future reference. Data engineer. Deals with the data. Data engineer deals with data. That is data management. That is data management. Data storage plus processing. Data engineer deals with data, that is data man, that is data storage and data man. Okay. Data engineering involves data engineering. Data engineering involves a data engineer, involves like handling data, ingesting data, handling data, ingesting data, ingesting, extracting, or storing data. Also involves so data, sorry, engineering. It does all with the data, right? Like filtering the data, transforming the data, processing data. So all this, whatever dealing with the data, right? Like merging the data, sorting data, analyzing data, or grouping data, analyzing data. Yeah, it also involves it also involves how to extract data, how to extract data, how to process data. What is the format of the data? And what is the destination of the data? That is the sources of data. What is the format of data? How to process data? And what is the destination of the a data engineer? If we talk, a data engineer designs and maintains an organizations entire data infrastructure is going to designs and maintains an organization's entire data infrastructure, including complex data pipelines and big data technologies. While an ETL developer, right, focuses on a specific extracting, transforming, and loading, right? So here, if we talk about this data engineering, right? Yes. Different sources, different sources. The sources can be databases. It can be databases, can be like IoT devices or apps. From here, extract, store, load, and processing, and finally target. Extract, okay. ELT we say extract, load, and transform. Data engineer designs and maintains an organization's entire data infrastructure, including complex data pipelines, right? And data engineer has got a broader role. You can say the data engineer has got a broader and architectural role, utilizing big data platforms and cloud services, whereas ETL developer has a specialized role, right? And if we talk like, okay, now coming to this Google Cloud, what is Google Cloud platform? Next, coming back, that is related to data engineer. He has got many responsibilities. On the other side, data scientist, data engineer does data management, data storage and processing. Data scientist, in a simple way, strategizes for the futures, recommendations for the future. He performs analysis, predictions, classifications, clustering, recommendations, right? On the other side, data analyst, visualizing the data of the past, in a simple way, visualizing the data of the past. What is Google Cloud Platform? Google Cloud Platform. Google Cloud Platform. or before that, okay, a GCP data engineer ensures data quality. He ensures data quality, data storage and processing, optimizing, collaborating with the data scientists, monitoring. Next is monitoring data infrastructure. Data infrastructure, monitoring data infrastructure, implementing ETL, implementing ETL, data security, data security. Data will be secured at each step of the process without any data leaks or data exposure. Okay. Data in 1 second. Data engineering is the process of transforming raw data into useful format that is further analyzed by the other teams, cleansing, organizing, and manipulating data using pipelines are some key responsibilities right of data engineer. You will be applying some data engineering principles on the Google Cloud to optimize its services. As a Google data engineer, you will have to collaborate with the engineers, marketing teams, product managers, sales associates. This collaboration will help you identify the customer behavior and enhance this optimization accordingly. Okay, if I talk about this GCP, key GCP services, GCP products or services. Key GCP products or services, right? Yes. We have got like a cloud storage, for storing data, cloud storage, right? Like GCSV for storing data. Secondly, BigQuery for fast querying, storage and analysis, large data sets. In a simple way, I say, right? Data proc, data proc for big data processing and analytics. For big data processing and analytics, and also like data bricks, PySpark processing, PySpark processing in GCP, data flow, right? Yes, for stream, batch data processing, for stream and batch data processing, cloud composer, right? Yes, like Apache Airflow, There is a power outage. Just wait for a minute. Just it will be rejoining the meeting. 1 second. Just there is a power outage. Again, just 1 minute. Cloud Composer Airflow, right? Yes. For automating and monitoring a data pipelines. For automating and monitoring data pipelines. Pub or sub. Can see, right? Yes. For messaging and data ingestions, right? Yes. Streaming means data which keeps on generating. See here, data flow for streaming and batch analytics. Like streaming means data which keeps on generating, data which keeps on incrementing. Such data we call like stream data. And batch data processing. Millions and trillions of records are involved, right? So you can see Google Cloud Platform, GCP, categorized into four. They're categorized into four. Compute. Second is like storage, big data, machine learning. Again, in computer. App engine, compute engine, container engine, cloud run. In case of storage, object, relational, non-relational or NoSQL, data warehouse. Object, relational, non-relational, data warehouse, right? Yes. For object, example of object, cloud storage. In the case of relational, example like cloud storage, relational VC2. In case of relational, cloud SQL, cloud spanner. In case of non-relational, for this. Cloud Firestore, Cloud Firestore. Secondly, big table. And finally, data warehouse, BigQuery. And in the case of big data, Dataproc, Dataflow, Databricks, PubSub, and also you can say BigQuery. Machine learning, Vision API, machine learning, right? Yes. Vision API, speech API, sorry. Vision API, speech API, translate API, machine learning. Machine learning, Vision API, speech API, translate API, and machine learning, right? So these are the main things, right? They're categorized into compute, storage, big data, and machine learning. That app engine, compute engine, container engine, and cloud run. Here, object relational, non-relational data warehouse. So object cloud storage, relational cloud SQL, cloud spanner. And in the case of non-relational or NoSQL, we have got cloud file store and big table, right? Yes. And data proc, big data like data proc, Databricks, Dataflow, PubSub, right? These things. Okay. BigQuery, Vision API, Speech API, Translate, and Machine Learning. Here, just I was talking about what is Dataproc for big data processing and analytics, Databricks for PySpark processing, Dataflow for stream and batch data processing, Cloud Composer for automating and monitoring data pipelines, Pipe and Sub for messaging and data ingestions, right? Yes. So in the compute, as I said, call this compute engine, right? Yes. This compute engine, app engine platform for building scalable web applications and mobile backends, and compute engine for running large scale workloads, and container engine, right? For running Docker containers or infrastructure, Google's infrastructure, and Cloud Run, fully managed is a compute platform for deploying and scaling containerized applications, right? Yes. And if I talk about the storages like cloud storage, it is a kind of it's a binary object, right? It's a binary or object data storage, images, media, and serving backups. And in the case of relational cloud SQL, cloud scanner, they are good for web frameworks and also for kind of RDBMS. Non-relational, right? Non-relational, good for hierarchical mobile and web, and good for heavy reads and writes. and data warehouse, right? Enterprise data warehouse like analytics, right? These things. Okay. So if you talk about this cloud storage, again, I doesn't want to enter into this practical part as of now. Storing and managing unstructured data like files, images, videos. Data is stored in the form of objects here within containers. We call them as buckets. Objects which are immutable, changes, modifications not allowed. They are piece of data, such as a file of any format. Buckets, I said these are containers used to store your objects. Projects will like all buckets and objects are associated with some Google Cloud project, and even storage classes, standard, nearline, cold line, archive. In this way, we got many things. Yes. And also like types of Google Cloud storages like Google Cloud Persistence, Google Cloud File Store, Google Cloud Storage, Google Cloud Storage for Firebase, and for transfer service, right? And persistent disks. So, okay, just observe, right? So what I'll be discussing as part of this course, right? Yes. So one second. And even talking about the PySpark, I'll be briefing you about that. It brought a revolution, even talking about that parallel processing revolution of bringing that distributed computations, right? Yes. So here I said data engineering is all about data pipelines, building data pipelines to get data from multiple sources into data lakes or data warehouses, and then from that data lakes or data warehouses to downstreams, building data engineering pipelines, right? And Google Cloud account will be just creating Google Cloud accounts. Yes, and later like cloud object storage and as data lake. Okay, now just check with this course content what I'm going to discuss as part of this course, right? In brief, in depth, I'll be discussing, right? So here majorly these are the products or services. Model 1 GCP data engineering fundamentals, Model 2 Google Cloud Storage, and Model 3 Cloud SQL setting up database, Model 4 BigQuery for building data warehouse, Model 5 Dataproc for big data processing, Model 6 like Databricks PySpark processing, the Model 7 Dataflow Apache Beam development, Model 8 Google Cloud Composer orchestration, and Data Fusion, Data Integration Service, and DBT Airflow and Terraform. So introduction to this Google Cloud Platform, GCP Data Engineering Fundamentals, getting started with GCP, storage and databases in GCP, Google Cloud GCS, setting up data lake using GCS, it's all things. Oh, Cloud SQL, setting up a Postgres database using Cloud SQL, right? And data ingestions, integrations, pub, sub, data flow, data processing and transformations, right? BigQuery for building data warehouse, big data processing, and ETL data pipelines using Dataproc, Databricks, PySpark processing GCP, ELT pipeline using Databricks in the integration of Spark on Dataproc and BigQuery, and Dataflow Apache Beam development, Cloud Sub, PubR Sub, Google Cloud Composer for data pipeline and orchestration, Data Fusion, Cloud Functions, Terraform, and data pipelines using dbt, Airflow, and BigQuery, right? Yes, these things. And machine learning in GCP and this BigQuery, Vertex AI, pipelines of ML, security monitoring and governance, and real-world GCP data engineering scenarios, data migration from on-premise to GCP, and designing hybrid data lakes, BigQuery and Dataplex, and project to flow, right? The two projects I'll be discussing as part of this course. So yes. Now, just what are the offerings from my side? Just check this live session video. Each and every session is video recorded. You'll be getting each and every session video and a soft copy of this class notes. Soft copy of class notes and assignments tasks to work with. A WhatsApp group for technical discussions where you can have direct interaction with me. A WhatsApp group. If you got any error, you can take snap of it and post in the WhatsApp group. Anybody can answer, I'll be answering it. Interview questions. Around 200 interview questions. And live interactive hands-on sessions. Wherever you want, you can do parallel along with me, right? The practical things. Live interactive hands-on sessions. Okay, these are the offerings, live session video, soft copy of class notes, assignments, tasks. Plus, apart from this, you will also get from DurgaSoft, as I said, once you get enrolled for this course, you will be getting Unix, Linux. Shell scripting videos, around 120 videos you'll be getting freely. You will get a free access to this. And apart from that, even MySQL videos, around 35 videos, right? You'll be getting access to this. Plus basic Python videos. Okay, you can just check with this, right? Yes. So becoming a GCP data engineer and GCP job market, right? This becoming a cloud data engineer. Now this is the correct time, right? Means cloud computing and data engineering skills are increasing in demand. Our companies are digitizing their solutions. And as stated in World Economic Forum, right? About the future jobs 2025 and 26, right? So in 25, we see the year of increased demand for data engineering, artificial intelligence, and cloud computations, right? Google Cloud professional data engineers are currently the high in demand for the skills in maintaining the process. And top companies also, like if you talk, the need of these data engineers. And according to the pay scales also, they've got the highest average salary as closely as data scientist. Even if you talk the top two highest paying jobs, data scientists and data engineers. Data engineers are the emerging jobs. Right. And even if you see many companies like Facebook, Intel, Microsoft, Amazon, they are interested in hiring data engineers. The great salary packages. Can see that you can demand for the salaries, right? For here, if you have got a good technical skills. So in the same way, if you have got a good package, in the same way, they'll be expecting the skills from your side. Even the tech giants like Google, Apple, Cognizant, Walmart, all they are offering high paying jobs for data engineers. So that is the course content, and you can see in the chart, right, in the Zoom chart, you can see a big message is given by the online team. There's course content details, their contact details, the payment details, the Google Pay, Phone Pay details, these things. Tomorrow also everyone can attend the session, same time at 3 p.m. using the same link to see more discussion, right? So the timing of the batch will be generally from 4 p.m. to 6 p.m. But initially the demos will be at 3 p.m. Next tomorrow also the session will be at 3 p.m. Yes. Any queries you got, anyone? Yes. Everything like clear notes and everything will be given clearly. You will be getting session videos, assignments, and anything to interact. You can have this WhatsApp group. Fine. So tomorrow also same time at 4 o'clock using the same link to see more discussion, right? Yes. So if I'm done with the queries, if there are no other queries, then I'm signing off for now. Meet you tomorrow. Same time at 4, same time at 3 o'clock, right? Tomorrow, 3 o'clock, using the same link to see more discussion, right? Yes. I'll be continuing from where we have stopped in the tomorrow session, right? Thank you all for your time. Thank you. Meet you tomorrow.